Hey everyone. Okay, so this is part two. I made one big long video, and then YouTube told me it was too long to even upload. So obviously too long to watch. It was over 20 minutes, and that's just too long. So what I'm going to do is break it into two parts. I'm redoing this now, but I've already got a bunch of the work done. Okay, so what this is a little bit more advanced probability, still independent. I'm rolling two dice at the same time. So maybe you're playing Settlers of Catan or Monopoly, or maybe you're gambling somewhere, hopefully when you're of legal age or your parents are. And there's games where your outcome is highly dependent on the number you roll, right? So obviously there's some more common rolls like getting a 7, getting a 6, and there's some less common ones like getting a 2 or a 12. And this is why it works that way, okay? So if I roll two dice, a red one and a blue one, I used a red felt and a blue felt. These are my possible outcomes. I can't get a 1 because the smallest number I can get is a 1 and a 1, which is 2, right? 1 plus 1 is 2. The largest number I can get is 12. So the range of numbers I can get are from 2 to 12. Now, how many different ways are there of getting number 2, like getting a 2? Well, there's only one way. One on the red dice, one on the blue dice. Okay, so there's one way of getting an outcome of 2. To get 3, there's two different ways I could do it. I could get 1 on the red and 2 on the blue, right, die. Or I could get 2 on the red die and 1 on the blue die. Those are different events, right, because they're different dice. A 2 on this and a 1 on this, or a 1 on this and a 2 on this, okay? To get a 4, I could have 1 on the red and 3 on the blue, or 2 on the red and 2 on the blue, or 3 on the red and 1 on the blue, okay? So there's a bunch of different ways of setting these up, and that's what this is. You can pause it and have a look at it if you like, but that's what this whole setup is, okay? So when I look at number 7, there are more ways to get a number 7 than any other number. I can get a 1 and a 6, 2 and a 5, a 3 and a 4, a 4 and a 3, and these are different, right? They look the same, but they're different. This is a 3 on the red dice and a 4 on the blue. This is a 4 on the red and a 3 on the blue, so those are totally different outcomes. The point is this: if I add up all of these, there are 36 different outcomes. I can just count them, but there's a shortcut to that too, and I'll get to that in a minute. Well, maybe I'll get to it right now. There are 6 outcomes here, right? And there are 6 outcomes here. If I multiply these guys together, I get 36 outcomes, okay? That's the same with flipping 2 coins, okay? So I've got 2 coins, and I flip them both. Well, there's 2 outcomes here and 2 outcomes here. My total outcomes are going to be 4. Or if I flip a coin and roll a dice, right? There's 2 outcomes here and 6 outcomes here. There's a total of 12 outcomes. So those become my denominators. So on here, the probability of rolling a 2, the probability of rolling a 1 is 0. But the probability of rolling a 2 is 1 out of 36. The probability of rolling a 3 is 2 out of 36. The probability of rolling a 7 is 6 out of 36, because there's 6 ways, 3, 4, 5, of getting a 7. Okay, and then to calculate the percent, you just go 6 divided by 36 times 100, and that gives you a percent. So when you're playing Settlers of Catan or gambling or Monopoly or any other dice game with regular 6-sided dice, this is something to consider. 7 is the most common one. Okay, good.